Hi guys, my name is Preeti Nalu and I'll be talking about Huntington's disease as a part of Bay Area SFN Youth, STEM Enrichment Youth, and NeuroKids. The information for this video came from the book Brain Facts by the Society for Neuroscience. In one sentence, Huntington's disease, also known as HD, is a heritable disease that impairs voluntary movement and cognition. 3 to 7 people of European descent are affected by this disease, and the disease is less common among the Japanese, Chinese, and African populations. The HD variant of the HTT gene is dominant, meaning anyone with a HD gene has Huntington's. In the Punnett square on the right, one of the parents has the HD gene and one normal HTT gene, and the other parent has 2 normal HTT genes. The child has a 50% chance of getting the HD gene, and with it, Huntington's disease. Moving on. The most common form of HD becomes active in the 30s or 40s, with death coming 15 to 20 years after symptoms. Juvenile HD comes during childhood or adolescence, and death comes 10 to 15 years after symptoms show. The beginning signs of Huntington's include irritability, mood swings, depression, small involuntary movements called chorea, poor coordination, and difficulty making decisions and learning new information. With the progression of the disease, chorea becomes more pronounced. There is increased trouble with voluntary movements like walking, speaking, and swallowing, and cognitive problems worsen. In addition to the symptoms I already mentioned, juvenile HD also includes slow movements, clumsiness, frequent falling, rigidity, slurred speech, and drooling. The impaired thinking and reasoning causes a decline in school performance. Seizures occur in 30 to 50% of children with juvenile HD. In 1993, HD was found to be caused by mutations in the HTT gene, which codes for the Huntington protein, on chromosome 4. The Huntington protein likely interacts with other proteins involved in signaling, transport, binding to proteins and other structures, and protecting the cell from self-destruction. The mutation causes excessive repeats of CAG, cytosine, adenine, and guanine. Normally, the trinucleotide repeats 10 to 35 times, but with the mutation, it repeats 36 to 120 times. The more it repeats, the more severe the disease. The expanded Huntington protein clumps cause neuronal dysfunction and death by disrupting the mitochondrial electron transport chain. The brain areas most affected by Huntington's are the basal ganglia, which takes part in voluntary movement, and the cortex, which takes part in cognition, perception, and memory. Okay, so let's move on to detection and treatments. In late 2015, Ionis Pharmaceuticals began the first human gene silencing drug. Ionis HTT-RX is an antisense oligonucleotide. In other words, it is a single strand of chemically modified DNA designed to interrupt the mutated Huntington protein. In spring 2017, the FDA approved deutetrabenazine for HD's chorea, the small involuntary movements. There is now evidence for biomarkers of Huntington's. Tau and neurofilament light chain, a component of the neuronal cytoskeleton, are at higher levels in the cerebrospinal fluids of those with HD.